I've started recording it. Hey, I mean, if you all don't mind me asking, how did you know that I did not start recording? Do you all get to see it somewhere, or it shows here? There you go. That's good catch, Manjal. Bravo, sir. So first name, last name, address, order date, product price, and I don't know, product company. Okay, so this is, say this is the kind of data that we have. So first normalization form, it actually says that everything has to be see it's, I guess it's easier to look it up. First normal form. um, okay, so first normalization form, okay, what does it do? If the domain of each attribute contains only atomic values, yeah, there we go. Yeah, so yeah, so what first normalization form says is every name, so let's say John Doe, okay, 3225 and Hatton, you all understand what I'm saying. So Manhattan Avenue, order, I don't know, is for a PS or Xbox 360. PS is 2 lane. Order date, let's make it today. Okay, see, you know what? Order, so this has to be the product. So let me actually cut it here. Product price, I don't know, $450. Xbox is by Microsoft, right? Xbox, or is it Sony?
Microsoft.
Microsoft, there we go. Microsoft. Okay. So now let's actually make it order quantity. Quantity. Okay. Okay. It's Christmas and I actually want to make the kids happy. So what I'll do, I'll actually get 3. So what I have here, yeah. So at this point, what? Yeah. So at this point, what first normalization says is, if I have another row in here, okay, that says, I don't know. So there's one for the same day. What else can I buy? I don't know. So like a NFL jersey or something for myself. So I'll say $150. And the product company is going to be NFL, right? So what first normalization form does is, it should have atomic values and there should only be, yeah, V. Yeah, man. That will make life complete. Xbox and V. Uh, but so what first normalization form says is, John Doe should only have one row. Okay, if John Doe doesn't have one row, that means that we are breaking the first normalization form. Okay, should have atomic values, which pretty much says single row per record. Okay, the second normalization form, if I remember correctly, is says is all these, okay, have to be dependent on a single key. Okay, if I call it say like a customer ID, or like a user ID, order date, product price, and product company all have to be dependent on, oh, I hate this thing, have to be dependent uh, on the user ID. Okay, but in this case it would actually break second normalization form also. So what we'll have to do is we'll have to come up with three tables: users, orders, and products. Okay, and so this is, so 2NF is all the columns have to be dependent on, have to be dependent, see this is what I would say, on a single column, but this probably might not be the right description. Let's go to 2NF. Put, put simply, a table if and only if, and every non-prime attribute of table is dependent. Yeah, see, they have actually made it more complex. But yeah, so long story short, it should say that if it we have user ID in the users table, okay, username uh, and user address should all be dependent on user ID. Okay, but if I say I have order quantity, okay, order quantity has no relation with, no direct relation, okay, no direct relation with the users. Order quantity would actually have a direct relationship with the orders table, so we'll have to switch it into the orders table. Okay, so what we can do is we'll split this thing into three tables. Okay, so users would have user name, user first name, user last name, and address. So yesterday we said that we wouldn't be using the namespace, so I'll remove it. Address. So the next question is going to be, if we say that we would want to uh, use first name, last name, and address, the big question is going to be, how are we going to say that this is a unique record? Okay, to say, or like to come up with a solution to make this a unique record, what we would need is a primary key. Okay, normally primary key in say in MySQL, okay, primary key in MySQL is going to be what is it, an identity column. Okay, an identity column, or like what, okay, so the right term is auto increment. Okay, would be auto increment. Identity would be used for in MS SQL. Okay, and these days there is a new way of handling primary keys. It's actually called GUID, or unique UUID. Okay, they are 23 digit, I won't say digit, but 23, the length of the alphanumeric key is going to be 23. Okay, and like I've already said, the key is going to be alphanumeric, and people generated from the from some GUID algorithm that they would actually use in their application. Okay, so yeah, so but for now let's actually make this an auto increment column. Okay, and we'll actually say that the auto increment column would uh, increment by 1. Okay, so now let's do the same for orders. Okay, so again, orders would have an order ID, then they would have order quantity, and then they would have an order date, right? And here let's have a product table. Product, damn it, products table. Okay, it would again have a product ID. Okay, it would have a product name. Okay, and then it will have a product price, and then we'll also list the name of the company. Now Now the big question is going to be, we want to track data, right? So we would have to find a way how we'll relate a user to an order and an order to a product. Okay, let's actually take this up and move this here. I thought it'll add a space. Okay, okay, yeah. So a user is looking for a product. Once the user decides on a product, the person would actually make an order or place an order, right? So the big question is going to be, how do we map the relationship between a user, order, and a product? Okay, so I actually had that right the first time. Yeah, so this is the right way. Okay, so a user likes the product, and once they like the product, they would actually place an order. Okay, so in here, one way of handling it would be to say that I would have a user ID in here and a product ID in here. Okay, but there is one small problem. The problem being, if the user wants to make multiple orders with multiple products, okay, at that point we wouldn't be able to handle such situation, right? Okay, so at that point what we'll do is we'll actually remove this from here, and we'll actually come up with a concept called associative entities. Okay, and again, just so you all know, this is part of the software development lifecycle and SDLC methodologies, uh, and this actually, I mean, this technically is like a real course uh, of for 3 credits. So I'm actually wrapping it up in like one session. So I I I'm not going to expect that you all understand every bit of it, but if you all want to read a little more, what I can tell you is, I mean, if you all want to read a book, I can actually send you all the name of the book that I have used. Okay, so feel free. And in the meantime, if you all have any questions, let me know.
Yeah, that's what I was thinking. I spent 6 months on it and just wrapping it up in 3 hours.
Exactly. So uh, associative entities. Now, what are associative entities? So, like the name suggests, okay, we are actually creating an association. The big question is going to be, what is the association for? Okay, like the name again suggests, we are creating an association between entities. So it's obviously more than one entities. Okay, so what we would do is we would say users is one. Okay, then let's actually give some space. We have orders, and then we have products. Okay, so uh, see, this is where I would like to use Visio, only if I have it. Do I have it? See, I actually have Microsoft Office, so I'm guessing I should. Okay, I don't think I have it on this box. Okay, no mind. So yeah, uh, so since I do not have Visio, uh, what I'll do is I'll actually say, yeah, I can actually put it right here. It shouldn't be a problem. So I would actually have a users to orders, okay, entity, associative entity, and then I'd have a orders to products associative entity. Okay, now this might not make complete sense at this point, but I'll actually put them here, and we'll actually understand what's up with these things. Okay, so users orders table, all that would have is the user ID. Okay, and then we would have the order ID in here, and yeah, and here in the orders products table, what we would have is the order ID and product ID. Fair enough. Okay, now let me add a space or like a return. Yeah, so now what we have at this point is we are actually able to track all the orders that are placed by a user and all the products that are part of orders that are again placed by a user. Okay, so since we have more than one tables, your guess is as good as mine. We'll actually use joins to retrieve the data. Okay, so at this point let me quickly ask you all if there are any questions. And if you all want to, I mean, even before you ask a question, if you all want to work on a real-time database, let me know. I'll actually provide the data, and I'll actually make sure that you all understand what's happening in that. But for now, let me ask you all if there are any questions with this structure or anything that we've discussed till now. I'll take that as a no, and let's keep moving forward. Okay, so at this point, uh, what we have is we actually have the ID. Okay, so now let's go back to our terminal for 1 second. Okay, we'll say, okay, so that's the table. Now we can actually use the command describe or desc to take a look at all the columns in a table. Okay, so here what it is saying is this is an ID which is an integer, and there are the name and address are varchars. Okay, but there is this information over here which is empty. Okay, which is talking about a key. Okay, but here I mean here we don't have a key, while here we are saying that this has to be some kind of a unique index. Okay, or some kind of a way where we would track data and keep the data atomic. Okay, so the way we would do that is, the way we would handle that is by a concept called primary key. Okay, so primary key is a way we actually index the data. Okay, uh, and by using this we are saying that we are storing a reference of the data in a location on the disk. Okay, where it is easily accessible. Okay, so I'll tell you all what actually happens when you store data. Okay, when we store the data, it is written to the disk. Okay, now one thing to understand is like how exactly do disk writes work. Okay, on a real system. Okay, the way disk writes work are, there is a spinning wheel that's going on. Okay, and then there is some kind of a pointy thing that is hitting those that is hitting the disk. Okay, and when we say write, it actually starts writing. Okay, the problem with that is, I won't say the problem, but when it starts writing, data kind of is everywhere. Okay, it's not in a single location. We cannot say that, okay, go to the northeast corner of the disk and you'll actually find the data. That doesn't work like that. Okay, the data is going to be written anywhere where we have some space. Okay, that is how what is it, that is how data is written to disk. And if we would want to arrange data in a specific format, that is why we go through a process called defragmentation of a disk to handle that issue. But coming back to our thing, what happens is, since data is written all over the disk, what we would have to do is, or like what primary key, I'll remove since. Okay, data is written all over the disk. Okay, now what primary key does is, or like the way primary key works is, the reference, okay, of these, of this data is stored in an ordered manner. Okay, it's very, it's completely ordered, it's sequential, and we actually can say that if I want a user with ID equal to 1, okay, at that point the request would actually hit the hit the primary key index, okay, primary key index, and then what primary key index would have is the value of the ID, okay, and then it contains the value of the ID and location information of the data, okay. So it contains these two things, okay, value of the ID, which is say like a user ID, and then it stores the location information of the data for user ID is equal to 1, okay. That's the beautiful concept about indexes, okay. So once we know the location, we wouldn't have to go through the whole disk looking for data. All you would do is hit the location, retrieve the data and send it back, okay. So that is how primary keys work, okay. And if you all want to go like understand more about the hardware aspect of primary keys, uh, yeah, look over the internet. There are a lot of resources, and people talk about how nodes work and how how data is arranged in like a leaf node, and then how intermediate nodes across it would come in and help it, and all that fancy stuff. But it's a very interesting concept, so go over it. Okay, so now this is the business reason or like the logical reason as to why we would use a primary key. Now let's actually look at the syntax as to how can we add a primary key. Okay, so for that again we would say create table. Table name is users. Okay, it's going to be ID int. Would say not null. Okay, and then we would say then we would give in the other columns. Say first name Waka 30, last name Waka 30, address Waka 80. Okay, after this we would say I think it's like this: primary key is ID. See, I'm pretty sure that it is done like this. Okay, and then let's actually run this and see what happens. Yeah, but since we already have a table, we'll have to drop this table. The way we would do that is we would say drop table name. Okay, so if you want to drop a table, we would say drop table name. Okay, and it works. Okay, so let's double check primary key. Yeah,
Sai, can you just hold for a second, Sai?
yeah, sure.
Yeah, sure, go ahead. Ah,
Okay, so this actually worked. Okay, so let's again do a describe on the table again. At this point, it is saying that it is primary. Okay, it has a primary key. We do not have it here. Okay, so it has a primary key. So data search is going to be pretty quick at this point. Now let's actually insert some data and see what happens. Insert into users values on John the Manhattan Avenue. Okay, now what I'll do is again I'll actually try. So let's actually break it and see what happens. Okay, we'll say that he's a different guy, but I'd still use 1. Okay, At that point, it is going to say that duplicate entry 1 for key primary. So it is not going to take data. And let's actually verify if this was like a warning or if it was like a real error. Okay, so the way we can verify it is we'll do a read on the table. At that point, it would only say that it has only one item. Okay, so the next thing is going to be, let's actually modify to 2. Okay, now the question is going to be, every time I'll have to increment it. Okay, every time I'll have to say 3, 4, 5 and so on, which is a little tedious given that, assuming that we actually work on a real environment. Okay, it actually, to serve this purpose, what we'll have to do is we'll have to always make a query to get the last id that is available, that has been taken, and then we would have to say that do +1 for that number and put it in the primary key. So to avoid that, what we can do is we can actually use a concept called auto increment. Okay, so let's actually take a quick look at auto increment MySQL. Okay, so okay, so let's actually use W3 schools. MySQL is pretty bad. Okay, so yeah, so the way you would actually set auto increment is by using this. Okay, on the column. Okay, so we would obviously say null and not null. We'll actually go through what is the difference between null and not null in a little bit, but for now, just take a look at auto increment. Okay, so again, what we'll do is we'll actually drop table users. Okay, let's go back and let's put not null. No, oh, what did I do? Auto increment in here, and let's actually run the table again. Okay, so now it actually, the query ran fine. Let's again do a describe on users and see if something's changed. Okay, so now it is actually saying that the this column, okay, is auto incremented. Okay, so we no longer have to worry about the id anymore. Okay, so now let's actually do insert into values. No, insert into table values. So here we'll have to do one thing though. Now that we are not giving in the value of the id, we'll have to specify what are the columns that we are sending in. Okay, so it's a address. Now we can actually skip the whole id issue completely. We can actually forget about it. What is it? 3225 MA. Okay, now we would say just the same example that we have done a while back. Even this one goes through. Now let's verify as to what is happening in the users table. Let's do a read. Okay, when we read, see, the id is auto incremented by 1. Okay, and sometimes, I mean, this never really happens, but there's one of those cliche uh, examples that everybody gives somebody else. The example is, what if your company wants to have records starting from 1000 or 100? Okay, and what if this step has to be 100? I don't know why people would do that, but what we can do is auto increment takes optional parameters called seed. Okay, so all we would have to do is auto increment 100 and that will take care of it. Okay, but really nobody does that stuff. It's one of those lame interview questions that people ask each other. Okay, so yeah, so now we are also done with auto increment, which is good. Now let's actually take one step backward and let us see what are the rest of the tables that we'll have to create. Okay, so the rest of the tables that we'll have to create are orders and products for entities, and then we'll have to create users orders and orders products in uh, as associative entities. So before we get to before we get to users orders and orders products, it is important for us to understand the concept of so now we have already seen the concept of primary key, right? Let's actually take a look at foreign key. Not copy it. Foreign key. Okay, so what foreign key says is, I mean, again, just like the name suggests, it is actually saying that if id, okay, is a primary key in one table, and if that id is being used in another table, okay, just to maintain relation and data integrity, we can actually use that as a foreign key. Okay, now there are two use of okay, now the biggest question is going to be, oh, can we use this only if we declare it as a foreign key? No, we can use it even without declaring it as a foreign key, but the catch is we would miss the indexing part. Okay, like I've said, indexing makes life easy. Okay, so that's why we would always need what is it, we would always need we would always need primary keys or foreign keys or unique indexes, or like in 2 minutes from now we'll discuss composite keys and all this fancy stuff to make our database run faster. Okay, so what is a foreign key? uh, a copy of primary key in a related table. Okay, we'll keep it simple. Okay, it is just a copy of a primary key in a related table. Okay, now uh, one other thing that I've mentioned is a composite key. Composite key. Okay, now in here what we have are two foreign keys, right? Order id and product id. Okay, now there are situations where I can actually say that order id is one and product id is one. I mean, the only reason to have this table is to track data, right? So if I say order ID 1 and product ID 1, order ID 2, product ID 2, order ID 3, product ID 3, and so on. At that point, what happens if I put in order ID 1 and order ID product ID 1 again? Okay, at that point, it is going to be an issue to data integrity. So what we would do is we are going to say that this combination, okay, this combination has to be unique. Okay, the way we would do that is by using composite key. Combination of keys has to be, is it have or has? Combination of keys have, I guess it's have, but combination is single. So dude, okay, no man. So combination of keys has to be unique. Okay, combination of keys, yeah, it has, right, has to be unique. Okay, so yeah, so this has to be unique. At that point, we would actually be putting an index, okay, for both of these. And if somebody asks you, do you have any idea about, let's say, like a multi-column index? Okay, at that point they are referring to a composite key. Okay, see, again, programming is always based on nativity and assumptions. Okay, so these are two key things that you all have to understand, because there was this guy who actually asked me if I have any idea about unobtrusive JavaScript. Okay, so for like a moment I was actually like as I was actually, I wasn't sure as to what he was asking about. Okay, but like, again, thinking about what obtrusive is to obstruct or like come in your way in some way. Okay, and what unobtrusive is the opposite of it, right? So an alert in JavaScript is going to be obtrusive, while say something like console.log is going to be unobtrusive. Okay, or for that matter, an ajax call, okay, is going to be non-blocking. Okay, while like a synchronous call is going to be blocking, which is obtrusive. So I mean, the point here being, uh, the questions that you might encounter are going to be, will obviously depend on the nativity of the person who's asking you the question, and the assumptions that he comes with. So make sure that you keep your mind open when you're listening to that question. So if somebody asks you multi-key index, composite index should be the one that pops into your head. Okay, so I guess I've covered the schema thing for all these. So let's actually put them into SQL. Okay, so we can reuse the same schema for, yeah, we can use the same schema for orders and products. Okay, so again, orders has unique ID. I guess this is order quantity and order date of order. So we can just say quantity. Now date. Okay, date. So MySQL actually has a date time uh, data type. MySQL date. Okay, date time. Okay, so we'll actually use the MySQL datetime. What does it? MySQL datetime data type. Okay. Now it is always important for us to understand as to what is the like what is the compatibility between, say, like a datetime format in MySQL to PHP versus a datetime format's compatibility to any other language. Okay, so Python, PHP, and Perl, they are super compatible with MySQL, so it would work. But when we to go from PHP to Microsoft SQL, there I've actually noticed a few issues. Okay, at least with datetime, because the assumptions on the Microsoft side are a little different from what we have in the open source world. Okay, so we would just use, oh sorry, we would just use uh, date, or we could even use date time. Okay, let's actually run this and see what happens. Copy, paste. Perfect, so it actually worked. Okay, so now let's actually do the same for, see, yeah, it's fine. Okay, so again, let's do the same for products. Okay, so products ID, name, and company. Okay, so ID, name, yeah, let's say company. Okay, so I mean, this is pretty simple, right? There's nothing to there's nothing much in here. So we just say paste. Okay, now let's do a show tables to see what are all the tables that we have. So we have orders, products, and users. Okay, now let's actually go back in here. Now we'll have to create the the query to build the associative entity. Okay, so let's begin with users, products. Create table users, products. Okay, here we do not have a ID key. Okay, but all we have are foreign keys. Okay, so it's a user ID. Okay, comma, I guess we'll have to int. Okay, order ID as int, and here we would actually have to give the foreign key references. Okay, so now let's actually go in here and see if they have a foreign key thing in here. Yeah, nice. Okay, yeah, so this is how we would actually define a foreign key. Okay, we would say foreign key the name of the column, okay, and then we would say it refers to the table name and the id in that table. Okay, so let's actually see how that's done in our example. So let's go back to shell. So we would say create table, users products, user id is int, order id is int. Okay, and we would say for hang on, did you have an underscore? No, we didn't. Foreign key, user id, references, users id. Okay, and then we have two foreign keys, right? So we would say foreign key again, foreign key, order id, references. Guys, is this legible? I mean, like, are you all able to see what I'm doing? Is it like clear to read?
Yeah, I can.
Okay. I would say order, orders, orders id, and again, like I've said, we would declare the primary key, right? So we would say primary key. Since it's a multi-column primary key, we would say user id, comma, order id. Simple enough. So let's actually take it from here and let's paste it. Oh, I have an error. So it says, so it did not have any issue with primary key, but it has an issue with the foreign key. Okay, primary key, user id, and order id. So should the primary key come before foreign key or what? Let's actually take that from here. Let's paste it here. And let's see what happens. Okay, so that didn't help. Oh, hang on. Yeah, that didn't help. So let's actually go back to. So let's actually go back in here and see. Yeah, so they actually have the primary key before the foreign key, which we have in here. So let's actually split it into multiple lines to see if we can look at the error. Primary key.
Can you have two primary keys? You cannot. I think so.
No, we should be. Yeah, I mean, see, that's the whole concept of a primary key. Should reference only one key, I'm guessing. Yeah, I mean, good. I mean, it's because that is the whole concept of a composite key. Let's actually check composite key MySQL. Yeah, see, you can actually. That's what I did, right? Did I put in an underscore or what? No, I did not. It's not case sensitive. That's for sure. See, I mean, this is another bad thing about MySQL. It doesn't give us a real error. It's like the stupidest database in that sense. Hmm. Okay, so order ID, user ID. Did I spell something wrong? So actually take a look at the example again. So he's saying this way. So let's
Do you
actually
think
take
single
this.
columns will help?
Say it again.
Single columns.
Single columns.
Mm-hmm.
What does that mean? I don't understand what you're
On
saying.
the other example I saw in primary keys, you said user ID, right? Try to put them in single columns because in the other, yeah, right there.
This one.
In the last example, primary key,
This one.
they are in single quotes, yeah.
Single quotes. Yeah. See, I don't think that
I
would.
don't either, but
Yeah.
you never know. MySQL is a little slow.
Yeah. Yeah. See, I mean, the only thing that I can think of is we are putting in both foreign keys and then we are also adding those two to the primary key. But I don't think, see, I don't think that would make a difference. But let's actually run this and see if this works. Because if this works, it's a little crazy then. So let's copy and paste. Create table user browse user ID foreign key. Okay, so that didn't work. That's nice. So something's wrong with my foreign key. It's not the primary key. So you have an error near user's ID. So did I name it something different or what? Select staff or we could say describe users. No, it is ID. Okay, so let's actually remove these foreign keys for now. Let's push this guy up. See, at that point, the problem is we wouldn't be able to check the relativity. So let me remove this one too. And let me begin with this one at a time. Copy, paste. Okay, so I'm saying create table foreign key user ID. Got a message. Okay, user ID references users ID. You want to fail. Okay, so I'm actually failing at the foreign key, so that's nice. So let me not worry about primary key for now. I'll take a look at the foreign key. So in here, do I have like a capital users or small? Hmm, bear with me, guys. I'm trying to find out what's up. No, the points to. I get it. Try avoiding primary key in brackets and make the foreign key lateral. No, it it looks like it is not able to find the ID column in the users. So I'm trying to figure out why is that happening. Select ID from users. So this query is able to find the ID, but this guy isn't able to find the ID for some reason. So tables. So it is plural. It is users. Okay. If I describe users, it is ID in here. Okay, that's what I'm doing, right? So let's try this. It'll actually be the lamest reason to not work, but foreign key, user ID, order ID, users. Okay, so it's not that lame. Not bad. Oh boy. So now I'll implement what he was saying. Try putting primary key in brackets and make the foreign key later. Yeah, see, I'm not even worried about the primary key at this point. I'm only trying to uh, fix that part. So let me implement uh, what she was saying, what Pooja was saying. So let's try this. I mean, it's another. I'll be a little surprised if this would work. Hopefully, it works though. I mean, it doesn't make any sense. This would work. Okay, so that didn't work either.
I was referring only to things in the foreign key or primary key, not the entire thing.
Okay. Foreign. Am I spelling it wrong or what? References user ID. Okay. Ah, I guess I have the. I have. I guess I know why. I mean, again, that's probably like the lamest reason if that is the reason. Jesus Christ. No wonder that worked. Damn. So, okay. Thank you for bearing with me. So, we were missing the all important brackets. Okay, so let me drop this guy now. Drop table, users, products. Let's actually rebuild it. So, the issue was I did not have brackets. So, see, that's how friendly MySQL is. It makes sure that everything is done as expected and it wouldn't even give you a reason why it's breaking your stuff. Okay, so let's actually make them lowercase for consistency. Now let's wrap this into brackets. Okay, so yeah, so the problem was I wasn't wrapping them into brackets, but again I cannot see a reason why we would need brackets given that it's it's not a multi value thing. Okay, so I mean the whole brackets comes from the concept of tuples. Okay, so tuples would be an immutable list where you can actually put in more than one value, but since a foreign key technically cannot have more than one value, it uh, I don't know why they would come up with this thing, but what are you gonna do? We would have to live with it. So we would say use column the foreign keys. Okay, and then we would give in the primary key. Okay, and one thing to keep in mind is we'll have to make sure that the the dependent tables, okay, or like the original entities are already in, okay, so or already existent. So now we'll copy this, let's paste it. I have another error. What's up? On line 7, so it's 1 2 3 4 5 6. Okay, so I guess I have a trailing. Yeah, I should get rid of that. So now finally, okay, so it works. So the correct syntax is going to be column column, foreign keys, and then the primary key without a trailing comma. Okay, now let's actually do a describe on users products. Okay, okay, so now it says both of them are primary keys. Okay, so we are good with that. Now let's actually go back and build the copy, and let's build the, let's get rid of this, build the, what is the last one, orders. Did we call it something different? Orders products. So hang on, so did I build a users products one? Okay, shit, it should be users orders. Okay, and then the last one is going to be orders products. Product ID. Okay, so we'll have to run both the scripts again. The reason being, I actually made this user, or like named it users products, but technically there shouldn't ever be a users products table. Okay, so let's actually drop that first. Drop users products table. Okay, so I would say drop table users products. Okay, that works. Now let's run this first. This would be users orders. Okay, that ran fine. Then let's come over to orders products. Okay, so orders products would have product ID, order ID, the foreign keys, and the primary keys, pointing to orders and the, it's products table, right? Oh boy, it's gonna fail. So I'll abort it. So I'll have to go in here and I have to say products, not product. Copy and I'll paste. Perfect. So we have all the tables now. So let's do a show tables command, and it gives us all the tables. Orders, orders, products, products, users, and users orders. Okay. So at this point, let me ask you all if there are any questions from your end.
No. So it is a foreign key, you can have only one. Oh yeah, I forgot. It's not the primary key.
Yeah. So yeah, foreign key we would only have one, given that there's only one column. But for primary key, what we can have is we can say that a combination of it is going to be the primary key. So at this point, what we'll do is we'll actually come up with some test data. Okay, so as always, we'll have to make sure that the data is inserted in a in an ordered fashion. Okay, So we cannot put data into any associative entities before we put data into the original entities. Okay, uh, so let's actually come up with 2 rows each, or like 3 rows each. So in here, it's getting a little too long. So, but yeah, no mind. So let's actually, so I think we already have 2 users, right? So let's say select star. Yeah, so we have 2 users. Okay, so now let's actually create 2 products. Insert into products. Okay, so ID is going to be already taken. So we'll just give name and the company. So the value should be Xbox. Company is Microsoft. Oh, it doesn't. It's not going to run. So copy, paste, and the second one is going to be I don't know, iPod, Apple. Okay. Then we'll actually say that user one. Let's actually make another uh, another thing. So let's say insert into products, name, company, value, Galaxy S3, Samsung. Okay, so now we'll say user one ordered, okay, Xbox and Galaxy S3. So that guy's an Apple hater. Okay, so that's why he bought both the products, or all his products are non-Apple. Okay, now let's say user two is an iSheep, is an Apple guy. Okay, so that guy ordered the iPod. Okay, um, let's actually create another user who's agnostic and who likes everybody. So let's insert another user. Insert into users, f name, l name, address, values. Hmm. I don't know. Pardon my lack of imagination. 3225. I would say B. I don't know what even you mean by that, but we have another user here. Okay. So now user three ordered all products. Okay. Okay. So now we'll have to write the queries for it. Okay, so what we have are what is it, so we would actually have 3 orders at this point, but hang on, no, we would actually have 1 2 3 and 3 6 orders, right? Because we are saying each product would have to be a single order, so we do not have a like a fancy shopping cart which would say we should take multiple items at a time. Okay, let's say we have an archaic lame shopping cart which would only take one item at a time. Okay, so the user has to say that I'll choose this and I'll click submit, and at that point we'll push a record in or we'll make the order. Okay, so at that point what we will say is we would need 6 inserts, okay, into the orders table. So orders table, so this is products, and this is orders. Okay, insert into orders, quantity and date. Quantity and date. Values going to be, let's say one. I think it's current timestamp. Let me look it up. MySQL current timestamp. Or we would even use now. Okay. Sorry. Okay. And then this is by user one. Okay. And product one. Okay. We got another. So the second product was Galaxy S3. User one, product three. See, I mean, this is simpler on the programmatic side. It might it I mean no, it's not might, it actually looks tedious on the like when we are building up the queries, but when we actually get to the programming part of it, I mean, I guess either one of you can take something like a best buy. Okay, and this is pretty much the base foundation schema for the not best buy, I'm sorry, eBay project that one of you all can take. um, okay, so insert into orders, quantity, rate, values, and this for user one. Yeah, so now let's actually copy this, and this is for user two and product two, right? Now the last one is going to be, I guess, all three. Let's take this guy up. Okay, so it is going to be user three, right? Okay, so these are the six inserts that we would make into the orders table. Okay, now after that we'll have to come back and say that we would want to we would have to get the IDs. Okay, and then we would have to populate the what is it populate the associative entities. Now once we are done with that, we'll actually look at the relational aspect of it and perform a few joins on it. Okay, so once we do the joins part, we would be pretty much done with the basic database stuff. The only two other things that will be left would be the aggregation. Okay, the aggregation of data, which would come when we actually perform complex joins, and then we would actually have to look at stored procedures. Okay, so let me quickly ask you all again if there is any question with the data, not with the statements, say like the inserts or creates or all that stuff, but with the business aspect of it, or with the requirement, because the requirement drives the code. So that keep that in mind always. So are there any questions? No questions? Okay, so let's take like a 10-minute break, and let's be back by is there a question?
No, it's not a question. But do you think it's okay for me to leave at 12:15 today?
12:15, what does that mean? As in 3:15?
Yeah,
So like
3:15.
1 hour from now.
Yeah, exactly.
Okay, yeah, I mean, Munjal, is that okay with you? Like, we'll actually end the class session at 3:15. No, oh yeah, 3:15. Yeah, okay, cool. So, given that you leave at 3:15, let's take around like a 5 to 7 minute break, and let's be back by like say 2:30. Yeah, let's be back by 2:30. So, like, we have 6 minutes. Okay.
Thanks, I
Okay, guys, are you all back? Are you there? Hey guys, are you all back? Okay. Okay, perfect. So both of you are back. Nice. Uh, Perfect. But are you all able to hear me? Okay, so that might be the problem. Can you all hear me? Yes, you can. Okay, perfect. Nope. Okay, so Pooja, did you like? Yeah, you also have. You don't have that. Okay, so you are not able to hear, right? Okay. you do not have the mic thing. So I don't know why you wouldn't be able to hear. Oh, she says, I think she's facing. Yeah. But by the way, when I actually right click, it says not connected to Pooja. The message is that not connected to audio. Oh, yeah, there you go. Oh, so that was a
Yeah,
network
now I
issue?
can hear you. I
Was
don't
that
know
a
what
network
issue.
issue?
I
Okay.
have no clue what issue it was.
Hmm. Okay. So what we have here is we actually have six queries. Okay. All of them are insert statements. Okay. So let's actually what's going on? Okay. Yeah. Let's actually insert these one by one. So let's actually make this small. Okay. Let's actually do a quick check of orders and see how is the data being populated. Perfect. So the data is being populated as expected. Okay. Now we'll have to keep it in mind that when we insert data programmatically, we'll automatically get the ID for which the data was populated. So the next step which we are going to do to insert data into the associative entities, you wouldn't have to manually get the ID. You would programmatically get it. Okay. Copy and paste. Nice. So select star from orders one more time. Okay. So we have six orders. Okay. At this point. Now let's say, yeah, not let's say, but it's actually one, two, three, four, five, six. Okay. So we have six orders. These are the order IDs. Okay. Now we'll have to do two things. First thing is to map the users orders. Okay. And then the second thing is going to be orders and products. Okay. And we have all the data in here. Okay. So it'll be insert into users orders, and since we do not have like an ID for this one, we can just give in the values. Okay. So the values are going to be the integers. Okay. The user ID is 1 and the product ID is 1. Okay. Then copy, paste, paste. So this would be the user one's orders, right? Now copy, paste. Oh, okay. So this would be the order information for user ID 2. Okay. Because user ID 2 is has bought an iPod. Okay. So 2, 2. Okay. Now the third thing is going to be, let's copy all this. Let's paste it here. And the only thing that we'll have to modify is the user ID. Uh, okay. So what we are saying here is, into the users order table, we are saying that user ID 1 has ordered product 1 and user ID 1 has ordered product 3. User ID 2 has ordered product 2 alone, and user ID has not product ID, but user ID has order IDs 1 and 3, or user ID 2 has orders 2, while user ID 3 has orders 1, 2 and 3. Okay, so now let's actually add semicolon so that MySQL doesn't go bonkers. So let's actually copy this and let's paste it. Okay, everything goes. Now let's do a quick select star from users products. Oh yeah, doesn't exist now. It has to be orders. Okay, now we'll do the same for orders and products. So it'll be simple. We'll just copy this, and since they are of the same schema, we'll just have to mess around with the orders. So, but when we are doing it this way, one very important to keep in mind is the order of the columns. Okay, so let's take a look at the order of columns for orders and products. Okay, we'll have to do describe orders products. It's first product ID and then order ID next. Okay, so we would have to, let's orders products. Okay, so the product ID. Okay, so let's scroll up here. The product ID is 1 and the order ID is 1. Product ID is 3 and the order ID is 2. For this is for the first one. Okay, the product ID is 1, the order ID is 1. The product ID is 3 and the order ID has to be 2. Wait, 2. Let me double check them. Yeah, 3 and 2. Okay, so then it will be, so are you all following how am I actually mapping the data? Are you all
Yeah, yeah.
okay? So there are no issues, right? Yeah, I'm actually going through the dictionary of information that I have here. So it is user one, order ID one. So here, okay. But when I go to products and value, products and orders, I would go from product one and order one. Okay, I'll actually be sending this file over too. So if you all have any questions, let me know. So it's going to be 2 and 3, and then 1 4 2 5 3 6. Okay, so it's 1 4 2 5 3 6. Okay, so let's actually take one step back again and see what have we just done. So the product ID is 1, okay, and the order ID would be 1. Okay, the product ID was 3, which is what is it? Some Galaxy S3, and the order ID is 2 because that was the second order that was placed by user 1. Okay, and then here the product ID is 2, which is an iPod. Okay, and the order ID is 3. The order ID is 3 is the order, that order was placed by user 2. Okay, and 1. Yeah, product ID 1, 1, 2 and 3. So remember, user 3 bought all the 3 products. So those are the order IDs. Okay, so now let's actually take this, copy and paste. So it says cannot add or update. Okay, so now this is the good thing about having foreign keys. So let's actually see what's happening here. Let's put an enter. Okay, let's make it big. So it says cannot add or update a child row of foreign key constraint fields on online purchase or those products. So it's saying that the product ID doesn't exist. Let's see, select star from products. Exactly, so that makes sense, right? So we do not have any items in the products. So like I was saying, it is always important for us to build the base entities first before we get to the associative entities. So let's build the products table. Products. Okay, so this is the products table, right? So we didn't insert this. I thought we did. Insert into products. Okay. So now let's actually go back. Now that we have the products table, let's go back and now insert the orders into the orders products table. Okay. So awesome. Everything went through well. Now let's again do a show tables to take a look at all the tables that we have, and let's take a look at everything in the order that we have added the information in. Okay, so the first thing that we did was to add the users. Okay, so there are 3 users. Then we added orders, or then we added products. Okay, okay, so then now that we have users and products, the users are starting to make some orders. Now let's take a look at the orders. Okay, so these are the orders that we have. Now to understand which user made what order, we would have to go to users orders. Okay, so user 1 made these 2 orders. Hang on. Yeah, so user 1 made this order and this order. Okay, now user 2 made this order alone, and user 3 made this order 3-1, 3-2 and 3-3. Okay, now let's actually take a look at the uh, orders and products data table to see what order maps to what product. Okay, so order 1, okay, maps to id product id 1, which means that the first order is about the product Xbox. The second order is about the product Samsung Galaxy 3. The third order is about an Apple iPod. The fourth order is about the Xbox. Fifth is about the iPod. Sixth is the Galaxy S3. Okay, so are we, like, are you all like at a good place with the data that we have put in? Because after this I'll actually start showing you all the joins. Perfect. So now let's actually, so today what we'll do is we'll just take a look at the inner join. Okay, given that we'll have to disperse at 3:15. Okay, we'll keep it simple. We'll just do the inner join. Oh, I mean, normally inner join is the most important thing. Okay, so left join and right join are a piece of cake. So let's focus more on the inner
If
join.
you guys want to continue, you guys can. I'll just catch up afterwards. I mean, I'll see the video later.
No, I mean, I think it'll be easy if you all are here, because
Okay.
I mean, mainly the MySQL part. Even the reason that I'm actually taking this effort to take you all through the shell is MySQL is a little tricky. I mean, given that the amount of errors that you would get, it's good if you all are here. So I mean
Yeah.
that's not a
Thanks.
problem. We can
I really
continue on.
appreciate that. Thank you.
No problem. We can do that on Tuesday. So next week it'll be Tuesday and Wednesday, right? Quick recollection
Yeah.
issues. Okay, Tuesday and Wednesday. So what do we have here? Yeah. So the inner join. Okay. So now to perform a join. Okay. Okay. The main thing that we would need is to perform a join. The main thing that we would need is a copy of data. Okay, that is relative to another table. Okay, that's the simplest way that I'll put it. Okay, we would need a copy of something, some column. Okay, be it an ID, be it a product name, be it a date, or be it whatever it is. Okay, we would need some kind of a copy. Okay, we need some kind of duplicate data in both the tables, which we can actually use. Okay, so now let's actually uh, begin with users and user products. So let's say describe users. Okay, and describe users orders. Okay, so we have the user ID information in users and the user ID information in the user orders. So we can actually perform a join between users and orders, user orders. Okay, to get the data, and the join would be on the user ID. Okay, so the syntax for that is you just select star from. Even before we get there, we'll talk about a concept of alias. Okay, so the alias is going to be we'll just select star from users. Okay, and you just say either as you, okay, or just you, okay, or not just you could even just say a, okay, and at that point you would say a dot f name. Okay, so when we use an alias we wouldn't have to go through the headache of using the whole table name. Okay, because again in a real-time database it is very common that the namespacing is an important thing. Okay, the namespace, the way the namespace would work is the database name underscore the table name underscore the column name. Okay, it kind of might sound a little foolish, but trust me, that is how real-time databases are built, and there is a good reason for that. The reason being, when we act for a DBA, okay, or for any kind of a person who's not a developer, to understand what the data is, namespacing helps very well. And the other case is going to be shared hosting. Okay, in shared hosting there are hundreds of databases living on the same disk. Okay, so the only way that we can actually identify one table to another table is by table name spacing. Okay, so the main point is that the table names are going to be very long. So in such cases what we would do is we are going to give the table name an alias. An alias is being an alias here is some kind of a common name or like a shorter name. Okay, so the short name for users here is capital A. Okay, once I assign the users object to capital A, I can actually say that so everything in that is in the users table is now part of A. Okay, so that is how we'll have to look at it. Okay, so that is the concept of aliases. Now that we understand the concept of aliases, let's get into joins. Like star from users u. So to join a table, okay, mainly when we are making an inner join, we would use inner join. Okay, the table that we want to join would be users orders. Let's call it UO. Okay, so now we are saying that let us perform a join between users and user orders, but we would have to say how. Okay, so the way we would represent how is by using on. Okay, on u dot id, which is users dot id, is equal to uo dot user id. Okay, we are saying that make perform a join uh, on this id. Okay, and do the join on the user id column that we have in users orders. Okay, at that point we'll actually get all the information. Okay, so the takeaway again from this one is going to be to understand the syntax. All that, so we are already familiar with this part where we are selecting data from a table. All that we are saying is select the data from the table and then perform a join, okay, on this table, okay, and return all the columns where this condition matches. Okay, so that is like the that's like the simplest way that I would put it. Okay, so break your query into three things. Okay, the first thing is selection of data, then join the data. Okay, once you join the data, you're filtering the data on this query. Okay, the query is where user id is equal to user id, I mean user id in the users table is equal to the user id in the users orders table. At that point we would actually get all the data. But fair enough, it's clear that we are actually getting repetitive records. the, and which is right. The reason for that is we actually have multiple records. That is the whole reason why we actually took it out from a single table and we are pushing it into multiple tables, right? So we'll actually get a lot of data. And here at this point, if you want to say I only want the orders for say user 1, all you'll do is you'll say u dot user id is equal to 1. Oh yeah, u dot id, right, is equal to 1. And always keep in mind that you are using the primary key. Okay, the primary key is id. Okay, yeah, is id in the users table. So use as much as you can. Okay, and make sure that you use the primary key of that table when you're using a where clause. Okay, so now we have successfully completed our first join. And what we'll do is let us join on orders to see the order quantity and the date of the order. Okay, in a join orders, I'll say o on. Okay, on we have, so what is the common thing between users orders and the orders? The order id, right? So we would say on u dot order id is equal to o dot id. Okay, and again we are just getting fetching the data for the first person. Okay, so now the quantity is 1. Okay, and they have ordered today at 2:37. Okay, now one thing that we can actually see is we have an id column here and we have an id column here. Okay, and the values are different. Now the question would be, how do we handle this ambiguity? Because I don't know what id column is this, I don't know what id column this is. Okay, so at that point we can use the same concept of what is it, same concept of aliases for columns too. We would just call them column aliases while the former was table aliases, right? So we would say u dot id, u dot fname, u. Okay, so here what I'll say is u as user id. Okay, u dot fname, u dot lname, because fname and lname are say unique. Then I'd say u dot address, comma, I would say o dot id as order id, o dot quantity, and o dot date. Okay, and I'll actually say from users u inner join users orders uo on u dot id is equal to uo dot user id inner join orders, right? We'll also want orders information on uo dot order id is equal to o dot id, where again we would query the data for the first user. So at that point there is no ambiguity anymore. We are getting the user id and we are getting the order id. Okay, so if you want to get the data for the second guy, you just say 2, and we'll get the order information for the second person. This would be the information for the third person. Okay, so this is how you'll actually make multiple joins. So before I uh, go in and do the joins uh, for products, let me ask you all if there are any questions at this point, because normally I take at least 1 or 2 sessions just for joins so you all understand. But do you all have any questions? Are you all clear this part? I'll take that as a yes.
I'm good.
So let's make our query look more ugly, make it complex. It made, but I know the concept, I can make it. What was the confusion, Munjal?
Syntax has made me confused, like how we are joining it. But I think I can fix it, because later when I'm gonna see the video and I'm gonna make a graph and all this thing, so I'll be fine, I guess. But it's just a little confusing right now.
Okay, so let me actually take this query and I'll actually break it up. Probably it's the format that's the issue, because when we actually write it in code, it it actually looks a little better. So the way we would do it is we would say we would have all the select columns, okay, on one line. Then we would say from users inner join uh, users orders on this, and then again you see, I guess I'll have to do this. It will make more sense like that. Yeah, on this, and then I would say inner join, and then I would say where. Okay, so at this point it actually looks a little better. Okay, where we're saying that we are selecting all these columns, okay, from this table, and then we are actually joining this yeah, joining the output of this, and then we are actually querying these tables based on this data. And once we have all the data for all the columns, we would then query that information again on the where clause. Okay, so now let's actually, now that we are here, we'll actually use this. Say inner join orders products, products, we'll call it op on the common item between orders and orders products is going to be the order id. Okay, so it will be o dot id is equal to op dot order id, and the final thing would be products p on op dot product id. Okay, orders dot product id is equal to p dot id. Okay, so now let's fetch the data, not just for number 3 but for all. Let's see what we get. You know what, but we wouldn't have to, yeah, we would have to declare this data too. So it will be pre dot I don't think it has a alias. So it will be p dot name, p dot staff and products. Okay, so p dot name and p dot company. P dot company. So yeah, I guess this should do it. So let's actually copy and let's paste it. Voila, there we go. Okay, so John Doe. Okay, so what we can do is going to be, we'll say order by user ID. Okay, so we actually understand what are the items for each person. Okay, so John Doe ordered iPod and Xbox. Okay, that's right. Then the second guy ordered Galaxy S3. The third guy ordered all the three products. Okay, so this would be the query. I'll actually send this whole thing over to you so you all can replicate the information again. Okay, uh, so this is going to be the way you'll actually fetch the data for everybody. Now if you all want to make it make the search a little more specific, you just say where user id is equal to 1, or u dot id is equal to, oh hang on, what just happened? Oh, order, yeah. Okay, so we'll have to get rid of order, so we just say where is equal to 1. Okay, so that would be the specific search. Okay, or if you all want to do based on a product search, you just say p dot id, which is product id, is equal to 1, which means that all the people who have Xbox. Okay, so it's user id 1 and user id 3. Or if you all want to say any Microsoft product, okay, so you would say p dot company. I would really say that we'll need an index at that point, but for now we can just ignore it. Okay, so we would actually get all the people again who have actually ordered a Microsoft product. Assume that its Xbox isn't the only product. There are like a lot of Microsoft products, okay, that have been ordered. At that point, this would be the query to fetch all the Microsoft products that were what is it? That were used. Okay, so at this point, we are like 5 minutes away from calling it a day. So it says you set alias for once only, right? Okay, so it's actually an alias. Okay, so alias. Okay, so the next thing that you're asking is for once only. So what does that mean when you say once only? Because so once per query, if that is the question. uh uh Munjal, did I answer your question? Can you make it more broad? Yeah, but how? I did not understand your question. um so like when you say you said alias for once only, so I'm trying to see if I've understood the question. uh I'm actually setting the alias like more than once, right? Like you said, once per query. Yeah, of course, once per query. So I mean, if your question is, are we caching the query or are we like storing the data in the memory? No. But over here it will be, so oh here. Okay, so I'm saying that I'm setting a column alias. Okay, I'm saying u dot id is user id. Okay, and then somewhere else I would say, yeah, o dot id is order id. Okay, and going forward I could even say, so let's actually make it fun. Let's see if, so Mac works. So I would say p dot name as product name. Okay, so at that point it would actually print product name. Okay, because name is pretty much ambiguous, because it could be a person's name or like a product name or something different. So to make it more specific, I'm saying I'm giving an alias for this column. Okay, and then here I obviously am making a lot of aliases for all the tables.
No, I mean my question is like, once you made an alias for a particular column or particular table, that's done. But I mean, is it gonna store forever? Those aliases gonna be there forever, or every time you want to use it, you make another alias?
Yeah, every time you use it, you'll have to make another alias. So
Oh, okay.
again, see
That's what the
alias.
question was.
So like I said, alias. How do I explain? I mean, again, aliases actually come from the concept of symlinks. Okay, so symlinks are symbolic links on Linux. Okay, so a symlink can be like a permanent link or just a random link. Okay, so MySQL, they've actually used the concept of symlinks and they've actually made them volatile. Okay, when I say volatile, it would only be valid for that execution period. Okay, so because behind the scenes, if you'll use any kind of a MySQL analyzer on or like a performance analysis tool, you'll actually see that how the data is assigned over to the alias. Yeah, so yeah, I mean we can probably take a look at those tools at a later point, but for now it is volatile. So once the query is done, everything goes away, nothing is stored. Does that answer your question? Ah, perfect. All right, so it's so yeah, so I'll ask again if there are any other questions than this one with data or anything. Oh, by the way, I did not ask you, Munja, like did you get a chance to go over the examples that we have yesterday from for OOP, like abstract class and interfaces? Sorry for my errors. Okay, yeah, again guys, make sure that you all understand abstract class and interfaces, because OOP is one of the concepts which people want you all to have a good idea on, because when you all go for interviews, OOP is going to be one of the important concepts that people expect you all to talk about. So just an FYI, it is good if you all understand it well. Okay, so if there are no more questions, I guess we can actually call it a day here, and I'll actually push the. Oh, yeah, one more question. What is it?
Okay, in this whole scenario, we made foreign ID, right? Did we actually use it somewhere? I mean, I'm
Who,
not really sure. Like we actually linked them with the foreign ID. I understand that one,
what was
but
your
like
question?
the foreign ID, which we made it
The
for like,
foreign key?
yeah, I'm sorry, yeah, foreign key, right?
Yeah. So again, so like I was saying, there are two ways of looking at it. The first way for a foreign key is to replicate the data or duplicate the data. Okay. So if we say select star from users and then say select star from users orders. So your question is, we have ID here and here. Okay, the same user ID, right? Your question is, we've actually went ahead and also done the foreign key part. Okay, or we have a reference key at this point. So like visually the difference isn't there. Okay, there is no difference even if we put a foreign key or not. The logical difference is going to be if we scroll up a little. Okay, scroll up a little. Yeah, so where did that go? So I'm actually looking for a bunch of errors that I actually got, and that is how foreign key. Yeah, exactly. So here it says cannot add or update a child row a foreign key constraint fails. Okay, so this is the first use of a foreign key. Okay, if we wouldn't have had a foreign key at that point, we wouldn't have got this error, and we would have went ahead and inserted trash data into it. Okay, so the first reason that we should have foreign keys are to maintain data integrity, and the second thing is to make the queries run faster, because foreign key is again an index. Okay, so we are also caching some kind of data which would make our queries run faster. So these are the two important things about foreign key. Does that answer your question, Manjal? Awesome, awesome. Yeah, so if there are no more questions, we can actually go ahead and call it a day, and I'll actually send over this the shrub file which actually consists all the data, and I'll actually send you all this video tonight.
Thank you.
Okay,
Bye.
enjoy the rest of your day.